Good afternoon, everyone. I am Sun Young-in from Dongguk University. First of all, I'm sorry to present my presentation in video because of new coronavirus. I hope it will be settled as soon as possible. Now, I will have a talk about an unbalanced recursive layer-based index method for high-dimensional data. And Yong-Woo Park from Sookmyung Women's University is a corresponding author for this paper. This is an index of my presentation. First, I will introduce the motivation and I will explain related studies about my paper. Next, I will present the proposed method, Unbalanced Recursive Layer-Based Index, and then I will explain the experimental result, and finally I will conclude my talk. In retrieval system, we construct an index for efficient searching. So to construct an index, convexol is one of the most famous and representative method. Convexol is a set of boundary points in the universe. That means minimal outermost points that contain all the points of given data set. As you can see in the figure at the left side, the convexol, it constructs a layer list respectively. So this is the first layer and the second layer. And as you can see, it is a balanced shape. However, UV layer constructs a layer list which does not completely contain the other layers all the time. It constructs an unbalanced shape, as you can see in the right one of the figure. So the first layer does not covers the second layer, so it looks like an unbalanced shape. So, however, these related studies have high index building time and small number of layers for large and high dimensional databases. Therefore, these are the contributions of my paper. First, we propose an unbalanced recursive layer-based index for improving the computation time of related studies. The proposed method divides the dimensions of a data set recursively until it has the smallest possible dimensions required to compute the convexol, like 2 or 3. And the proposed method divides the dimensions of database dataset, input dataset recursively until it has smallest possible dimensions required to compute the convexol. And it also constructs an index with a greater total number of layers for efficient query processing. Second, we show the performance advantages of the proposed method through various experiments. We compare the index building time and the total number of layers and precision. Next, let me explain the related studies. Onion builds a primary layer from the input data set by finding edge objects. And HL index is a combination of layer-based and list-based index construction method. And ACH index is an approximate method to create skyline layer first and then divide the input dataset using a grid partitioning algorithm with virtual points, and finally constructs an index by combining each convexol from the partitioned datasets. And last one, unbalanced layer-based indexing method, which reduces the construction times of the convexol. the outside layer of UV layer does not include other data objects. However, its index construction time is faster, up to 99 times than convex hull. So these are notations for the presentation. DS means an input data object, and O means data object, each data object in DS. And N is the number of data objects, and D is the number of attributes, so it means dimensions, the number of dimensions. And A means the attributes, each attributes of DS, and sub DS is the partitioned dataset with divided dimensions. Now, let me present the proposed method in this paper, unbalanced recursive layer-based index. First of all, I will have an overview of the proposed method, and it consists of 3 steps. First, recursively dimension division step. We divide the dimensions of input data set into k sub data sets. It means we divide the dimensions recursively until there are 2 or 3 divided attributes, and these are the smallest number of attributes for calculating convex hulls. And next, we in building sub-convex hull step, we build sub-convex hulls in each sub-data set. And the last step, UV layering step, we combine the sub-convex hulls to construct the final unbalanced recursive layer-based index whilst removing duplicate objects. Now I will explain each steps in detail. So in the first step, recursively dimension division step, so we divided dimensions of input data set, and this is an example. Here, the input data set has 6 attributes. Here is the attributes, and there are 6 attributes. So we divided into 2 data sets. So the first data set and the second data set. So the first data set, the first sub data set has 2 attributes, and the second sub data set has 4 attributes. And next, we divided the second data set recursively. So finally, we have 3 data sets, divided data sets, and it has 2 attributes in each data set. So yes, this is the first step of the proposed method. Yes, and we mapping the 3 sub data sets on 2-dimension space. And next, in the second step, we build sub convex hulls in each sub data set, and this is an example. So you can see, as you can see, we construct a convex hull in each sub data sets like this, and as you can see, O1 is a convex hull object in sub data set 1, and also O1 is a convex hull object in second sub data set, and also O1 is a convex hull object in third sub data set. So that means it has duplicate objects. So O1 and also O4 04, 04. So in the last step, we combine the sub-convex hull from each sub-data set whilst removing the duplicate objects, such as 01 or 04. Next, I'll show the experimental results. First, we compare the index construction time as dimension D is varied. For your convenience, I will call balanced recursive layer base to simply UBR. Okay, UBR reduces the index construction time of UB layer by 1.3 times on average and by 66 times on average when compared to the convex hull. And next, we compare the total number of layers as dimension is varied. We compare to the convex hull method, UBR constructs 19.5 times more layers on average. Next, we compare the index construction time again when the number of input data is 200. Because for the previous experiments, we cannot conduct the experiments of convex hull when dimension is over 9. So we compare the convex hull less than 9. Dimension is less than 9. Because the construction time of convex hull is really high, so we decrease the number of input data set and we conduct the experiments from dimension is from 4 to 10. And UBR reduces the index construction time of UB layer by 2.5 times on average and by 6,073 times on average when compared to convex hull. So the UBR reduces the index construction time more and more when dimension is high. Also, we compare the total number of layers as dimension is varied again. UBR constructs the layers 2.7 more than convex hull on average, and UBR constructs the layers 1.6 times more than UB layer on average. So this is the conclusion. We have proposed balanced recursive layer-based index, which increases the total number of layers and reduces the index building time. So in the retrieval system, the query finds the layer by layer. So when the layer each layer contains more objects, the query processing time is high. So we increase the total number of layers and we reduces the index building time. And it consists of 3 steps. We first divided the dimension of input data set recursively, and we build a sub-convex hull in each sub-data set, and we finally combine to construct an unbalanced recursive layer-based index. So as for the future work, we will improve the index construction time again, and we will improve the accuracy of this proposed method, and also we want to apply the proposed method to the real world applications. And these are the references of this talk. Okay, thank you very much.